Hi there. Let's take a look at the practice problems that I've set up for you. This will be practice problem set 1 from your Canvas page. If you'll take a look, you'll find them on the page worked out. But let's take a look at them and talk about how these are in fact solved. The first one says, a farmer measures the distance around a rectangular field. The length of each side of the rectangle is found to be 38.44 meters, and the length of each short side is found to be 19.5 meters. And we want to find what the total distance is then around the field. So we're really looking at the perimeter of this rectangle. You can see the way that I've got it drawn here. We've got the length, the long side, marked as 38.44 meters, and the short side, the width, marked 19.5 meters. And by inspection, you can see right off that in terms of significant digits and accuracy, we've got a difference there because the width has a 3 significant figure number with 1 decimal place, where the length is a 4 significant figure value with 2 decimal places. So we've got an inconsistency here in terms of significant figures and what we can use to determine the accuracy. So in this problem, we would have to refer back to the rules for significant figures to determine what is going to be the most significant answer. Well, in this problem here, again, what we're asked to find is the total distance around the field. The solution then is really asking us to solve for the perimeter length of the field. Why do you think the farmer needs to know the total distance? Well, maybe he wants to put a fence around his land and he needs to know how much material to buy. So it just becomes a matter of adding the lengths together, 2 times 38.44 and 2 times 19.5, adding those values up, and we end up with a perimeter value of 115.9. Well, you notice here that we only have 1 significant digit in the decimal place. We have 4 significant digits, but we only have 1 decimal place. So for addition, the rule says the number of decimal places in the result should equal the smallest number of decimal places in any term of the sum. Okay, so you have to pay attention to those rules for significant digits, and especially when you're dealing with decimal places. So let's look at problem number 2. Problem number 2 says the speed of light is about 3.00 times 10 to the 8th meters squared. So 3 times 10 to the 8th meters squared. They've asked us in the problem to convert this to miles per hour. So we're looking for the speed of light, which is generally given as c, the velocity, and we're looking for miles per hour. So what we have to do is take what we're given and determine what conversion factors that we're going to need to set this problem up so that we can do a little factor unit notation. So in a vacuum, the speed of light is 3 times 10 to the 8th meters per second. And we know that the conversion from miles to meters, 1 mile is 1,609 meters. So now we've got some values for our conversion. The solution then says we're to convert the speed of light in meters per second, 3 times 10 to the 8th, from meters per second to miles per hour. So we've got some time units that we're going to have to convert as well. So we've got our conversions from miles to meters. Now what we need to do is set up a little factor units, if you can't do it in your head, to turn hours into seconds. So we know that in 1 hour there are 60 minutes. So the first factor that we're going to use is minutes and hours. So 60 minutes, set it up so that we have minutes in the numerator, hours in the denominator, because we want to lose the hours. They're going to cancel out. That's the unit. And then we have to go one more step. That one more step is converting to seconds and being able to cancel out the minutes. So in 1 minute, we have 60 seconds. So now we've set up our factor units so that we're canceling out both the minutes, and we are left with just the hours in seconds per hour. Okay, so it's just a matter of 60 times 60 gives us 3,600 seconds in a 1 hour period. I said earlier canceling, but we're not canceling the hours because that's what we want left over, because we're going to use that in the final answer to get rid of our seconds in our speed of light. So now we take our speed of light representation, that value, 3 times 10 to the 8th meters per second, and we set everything up then in a factor units method. So what we're going to do here is, here's our speed of light in meters per second. Here's our conversion from miles to meters, and here's our conversion in seconds to hours. So our meters are going to cancel out, our seconds are going to cancel out, and what we're going to be left with is miles per hour. So you can pull out your calculator, multiply 3 times 10 to the 8th times 3,600, divide it by 1,609, and you will be left with 6.71 times 10 to the 8th, and now we're in miles per hour because our seconds and our minutes are gone, or our meters are gone. So now let's look at problem 3. Problem 3 is asked us, if a painter is to cover the walls in a room that's 8 feet high and 12 feet along the side, what's the surface area in square meters that she must cover? So we're looking at a wall that's 8 feet tall, 12 feet wide, and again, the first thing we have to look at is, what does our accuracy or our significant figures tell us about these values? The height, 8.0, is one significant figure with no decimal places. The length is 12 feet, two significant figures with no decimal places. And again, we're going to need our conversion factor from meters to feet, because in the stem of the problem, they want to find out what it is in square meters. So the solution says that the problem implies that there are 4 walls to be painted. Okay, so we've got 4 walls in a room. It says here, in a room. Find the surface area for one wall by converting feet to meters, where 1 meter equals 3.28 feet. Then multiply times 4 walls, and that will give us our total for all 4 walls in the room. We're going to let A equal the surface area of one wall, and then we're going to put a little subscript on here, A total is equal to the total surface area then of the room. So we set up our problem with the little factor units again. In the first parenthetical expression here, we've got the width, 8 feet, with our conversion factor, 1 meter is 3.28 feet. And the second one for the length, 12, times that same value, 1 meter divided by 3.28 feet. Okay, so now if you, again, pull out your calculator, 8 feet divided by 3.28 feet, the feet units cancel out. Over here, 12 feet divided by 3.28 feet, again the feet units cancel out, so that in both terms, all I'm left with is meters. So the value then should be 2.44 meters times 3.66 meters to give us a value now of square meters, because meters times meters gives us square meters, 8.92 square meters. We've got 2 decimal places here, we've got 2 decimal places here, so we've got our 2 decimal places squared away here. Now we go back to the fact that we have 4 walls in the room, so we're going to multiply that value times 4, and in doing so now we have 35.7 square meters, or approximately 36 square meters. Why 36? Because we need to drop the 0.7, because in both cases we had no decimal point value. Problem 4. Problem 4 asks us to do a little trigonometry. So we have to rely on our values for trigonometry, some of our trig functions, and a little bit of Pythagorean theorem. We're looking at a right triangle. We know that this forms a 90-degree angle. We've got 2 other angles, the opposite and the adjacent. So for this triangle, they want us to find first the length of the unknown side. Well, the hypotenuse is given as 9 meters. The side adjacent here is given as 6 meters. So this adjacent side of phi then becomes a length that we need to find the unknown. Number 2 asks us to find the tangent of angle theta, not the angle, but the tangent of the angle theta. And then 3 asks us for, again, not the angle of phi, but the sine of phi. So the easiest way to start this off is invoking the Pythagorean theorem. Okay? So, knowing that the length of side B adjacent to the angle phi, so here's angle phi, here's the angle opposite, so this must be the adjacent, and the length of the hypotenuse, well, here's our hypotenuse, 9 meters here, so there's our hypotenuse. We can solve for the length of side A opposite angle phi by using the Pythagorean theorem. So, to set up the Pythagorean theorem, we've got the hypotenuse squared is equal to side A squared plus side B squared, side B being the adjacent. So let's move terms around to try to simplify this expression. Since we're solving for A, why don't we subtract B squared from both sides? Subtracting it from this side allows us to cancel those out. So B squared minus B squared, it's gone. Now we do the same thing to the other side, minus B squared, so that we're left, let's move our terms around to make it a little more convenient. We have A squared right there is equal to C squared minus B squared. Okay, it just makes it a little easier to work with the problem. We're solving for this unknown using these 2 knowns. So the next thing we need to do then in the expression is we need to get A by itself. We need it to be a singular number, not a squared value, not a square root. So by taking the square root of both sides, on the A side, the square root cancels out the square, and we're left with just A. Simple algebra. On the other side, though, we can't do anything with it at this point, so we have to leave the radical, the square root, over the top of the values. So let's insert our values for C and B, 9 meters and 6 meters. And now we can solve for those values. 9 squared gives us 81 meters squared. 6 squared gives us 36 meters squared. Now I can combine these 2 terms, subtracting 36 from 81, and I have 45 meters squared. Now I can remove the radical by taking the square root of 45 meters squared, and the square root of 45 becomes 6.71, and meters then now becomes just meters and not square meters. Okay, so now we know side A. So the solution then for B, or number 2. Knowing then the length of side A adjacent to angle theta, here's angle theta up here, and the length of side B opposite to theta, well, here's the side opposite to theta, we can solve for the tangent of theta by using the trigonometric function. The trigonometric function says that tangent theta is equal to side B, the opposite of angle theta, side A, the adjacent of angle theta. Well, we know those values now. We know that 6 meters is the side B. We know that the adjacent is now this value on top, 6.71. So now it's just a matter of dividing 6.71 into 6, and we end up with the tangent of theta is 0.894. That's not an angle, that's the tangent. We'd have to take the inverse tangent of both sides to come up with the angle that's represented by that value. The last step is asked us then to determine the sine of phi. So here's phi. We want to find out what the sine of that angle is. So again, going back to what we know, knowing that the side A opposite phi, here's side A opposite, and the hypotenuse, we can solve for the sine of phi. Again, using the trigonometric function for this time sine phi says side A, the opposite of phi, well, here's phi, there's the opposite, divided by the hypotenuse. Just now put in the numbers, 6.71 again, that's this side. 9 meters is the hypotenuse. And again, we have the sine of phi is 0.746. Okay, not the angle, but the sine. The last problem then asks us to determine, with the radius of the planet Saturn and its mass, we want to find the density and the surface area. So the radius of the planet Saturn is given to us. You can find that in the book. You can Google it. Saturn is 5.85 times 10 to the 7th meters as its radius, and its mass in kilograms is 5.68 times 10 to the 26th kilograms. Okay, so we've got this set up in our MKS units. So 1, find the density of Saturn in grams. Our value here was given in kilograms. They want it in grams and in per cubic centimeter. Well, you can see up here we were given the radius in meters. So we've got some units that we have to convert. So density given by the letter rho is equal to the mass divided by the volume. Okay. The second one then, they want us to find the surface area of Saturn in square feet. So the surface area is equal to feet squared. So let's create a little given here so that we put everything down and we understand what we have and what we don't have. The radius of Saturn then is given to us as 5.85 times 10 to the 7th meters. The mass of Saturn in kilograms is 5.68 times 10 to the 26th. Now the next two relationships here, you can find in your text, you can Google it, there are lots of places to find it. If this were a calculus class, you'd have to derive these. But very simply, the standard relationship says that the area of a sphere is 4 times pi times the radius squared. The volume of a sphere is 4/3 pi times the radius cubes. So those two givens are going to help us solve the problem. The solution then for part A, the density, rho, is the mass divided by the volume. The volume of the sphere then, 4/3 times pi times the radius cubed. So let's start off by doing some conversions. We're going to convert meters to centimeters because that's what the problem asked us. So let's take our radius, 5.85 times 10 to the 7th. There are 100 centimeters in a meter. So now all I have to do is multiply 5.85 times 10 to the 7th times 100 meters. My meter units cancel out, and I'm left with a centimeter value, 585 times 10 to the 7th centimeters. Okay, those two zeros there we've moved over so that we have 1, 2 spaces moved to give us that value. So now we have the radius in centimeters. So let's look at the volume then of Saturn. The relationship says 4/3 times pi times the radius cubed. So 4/3 times pi, we're going to take this value, 585 times 10 to the 7th, meters cubed, okay? That's the radius cubed. We multiply these terms out, 4 times pi times this, divided by 3, and we end up with 839 times 10 to the 27th cubic centimeters. Okay, now the next part of the problem, we need to convert kilograms to grams. The mass of Saturn was given to us, 5.68 times 10 to the 26 kilograms. We're going to convert that. There are 1,000 grams in 1 kilogram. So the kilograms are going to cancel out. We're going to be left with grams, just like the problem has asked us for. So 5.68 times 10 to the 26 times 1,000. Again, that tells us very simply we're going to move this decimal place 1, 2, 3. So we'll add a 0. We have the mass now in grams as 5,680. So now we have our mass in grams. We have our volume in centimeters cubed. So now all we have to do is plug those values into the density relationship. So the density relationship, as we saw up here, grams divided by cubic centimeters. So the mass of Saturn in grams, the volume of Saturn in centimeters. All I have to do now is divide these values through. 839 into 5680. I've got a difference there of 1 exponent between 27 and 26. Okay, so we'll take care of that with our factors of 10, so that we have 6.77 times 10 to the minus 1, because here we've got a difference here, 26 and 27. So in the denominator we have a minus 1, gives us then a value then of 0.677 grams per cubic centimeter, okay, because we just moved this decimal place 1 over, and that takes care of that 10 to the minus 1. The second part then, the surface area, A, the surface of Saturn, converting from meters to feet. 1 meter is 3.28 feet. Put that into our relationship. We can use, again, our factor units method here. 5.85 times 10 to the 7th meters. There are 3.28 feet in 1 meter. Our meters are going to cancel out, and we're going to be left with feet because they've asked us to solve for it in square feet. Now we know that the area of a circle, or a sphere rather, is 4 pi r squared. So we're going to take 4 pi r squared, plug in our values. The radius squared then is this value, 19.2 times 10 to the 7th. Put it in for r, square it, multiply it times pi. I hope you're using that pi key on your calculator and not putting in 3.14. Multiply it times 4, and we end up with a square foot value for Saturn of 463 times 10 to the 15th feet squared. So those are the 5 problems. It just, if you haven't done it in a while, it just takes a little practice and some rote. So go back and take a look at these and go to school on these. Learn from what I've shown you here to brush up on your math skills. Thank you very much.